So there are a couple things you're being asked to do here that I want to have us look at together. Getting started or restarted, looking at topographic maps and interpreting them specifically to understand how glaciers have sculpted the landscape is one thing we're going to look at together. And in particular, we're going to talk through question 1 as a way to think about how do we look at topographic map, how do we create a cross section from it. So we haven't done a lot with creating cross sections, but we've used them multiple times. So this will be a chance for you to see a little bit of the process that goes into creating one of those cross sections. And then from that information that you've collected in this visual format, you're going to be able to answer some of these other questions. So you're looking at a couple of different maps of glaciated areas. So this is Harvard Glacier. This is what you're looking at for part of what you're doing for this first one. Right, so you're looking at, in particular, when you get down here, Harvard Glacier, you're going to be adding some information here. And then Yosemite Falls is the other quadrangle you're looking at. That's this one. And you're looking at a couple different cross sections here. One from S to T, and this is across Snow Creek. So this is a a fluvial created valley landscape. And then G to L. And so this is part of Yosemite that is one of the lower valleys. And so you're looking at some of what that shape to the valley looks like as well, and doing some interpretation about how you can tell that that one was formed differently from the other one that you're looking at in the S to T cross section. Okay, so let's go back to the beginning of activity 1. So there is a graph provided for you, and you're going to use the draw tools in Word, and I'll remind you of how to use those to create a topographic profile for ST here. So you're basically looking at the topo lines, the contour lines on here, to try to figure out how high is the surface of the land from S to T. So let's pull up, I'm gonna minimize this a little bit and pull up our chart on the side. Okay, so this is the chart that you're putting this information into. So as early as question 1, you're being asked to put information into this chart. And then you're going to see that there are some other questions. Question 5, when you get to thinking about Harvard Glacier, you're putting information in on this other side of the chart. But they're both looking at feet above sea level. So from sea level here all the way up to 9,500 feet above sea level. So up in the high Sierras in Yosemite, which is the topo map we're going to start with interpreting. And it's telling you the starting point and the ending point of the cross section you're making. So again, when you get to Harvard Glacier, you're just going from point A to point B, and that's what these 2 letters up here are telling you. For Yosemite Falls quadrangle, we're doing 2 different cross sections, and you're doing them both on here. So we're going first from S to T, right? That's this cross section. We'll do that together. And then you're going from G to L, and that's this cross section down here. And we'll talk through how that would be different from the S to T one. All right, so if you have this open for yourself, you can draw this in as well. You'll want to go to draw and just choose a color you want to work with. You're going to make your topo line dots across here. And part of what you want to do is be as accurate as you can. I'm not going to ask you to take out a ruler and be extremely precise the way we might actually if we were in the lab doing this in person, because it's a lot easier to sort of get your ruler up there and have everything to scale. But what I do want you to make sure you're doing is sort of look proportionally at where things are. So you can look at maybe where the stream crosses this cross section, and it's approximately in the middle of that transect from S to T, right? So when you're coming over here, you know that the contour line that's right at the creek is going to be about in the middle of this cross section from S to T. So you just want things sort of spaced out approximately correctly when you're doing this. All right, so let's start by looking at S, and S, luckily for us, this is set up nicely, is along one of these dark contour lines, and we know those are typically the ones that have the labels on them. So we can just follow that along to the side. It says 7,800. So I know that here I'm going to find 7,800. So there's 8,000 is this one. So 7,800 is about right here. So I'm going to make a dot there. So that's my starting point. And then what I'm going to do for myself, I find this a little easier. So I'm going to go over to the other side of the cross section now for T and look at the map. And this one's also a dark contour line. So it's labeled, it's 8,200. So I'm going to go over to T, find 8,000, 8,200 is about here. So now I have my two endpoints to the cross section. I can see that one is a little bit lower on the S side than the other side. T is up a little bit higher. And now I'm going to try to fill in some of these data points in the middle to figure out what is the shape of this valley right here. All right, so the simplest way to do this, I think, is to use the labeled contour lines since you have enough of them that you cross. So I can go to this next contour line, follow it along. This is 7,600. And then you also want to sort of proportionally estimate your distances, right? So I'm going to say I cross it here, and that is about maybe a quarter of the way across the transect. So it's at 7,600. So here's 7,500 again, is this line. So about a quarter of the way across, I'm going to be a little above that at 7,600. So that's that second contour line I cross. The third one here, if I follow it far enough along, is 7,400. And you also can just read what the contour interval is and count the number of contour lines as needed. So that's 7,400. And that is a little more than a third of the way. It's pretty close to the stream. So it's pretty close to halfway. So 7,400 is going to be about here. And it's not quite in the middle, but it's a little bit over. So I'm going to say, okay, that's my 7,400 contour line that I'm crossing right there. And then the stream is going to be at the lowest point in the valley. It's pulled downhill by gravity. So if I look at how many contour lines I have to cross, the fainter ones, it looks like I go across one here, and then maybe a second one is where I am at the stream, and that's where this transect is crossing the stream. And so I know the contour interval is 40 feet. So I've gone down about 80 feet, 2 contour lines to get to the stream. So I went down from 7,400 to about 7,300 at about halfway across. So I'm going to put my point for the stream right there. And now I want to, again, go look at those dark contour lines that I cross on my way from the stream all the way over to T. So I'm crossing 7,400, just a little ways over again. So I'm going to put that here. I want that to be about the same height as this other one over here that is 7,400. And then it looks like I go 76, 78, 8,000, and 82. So these are all fairly close together, stepping up by 200 each time. So I know that not too far over, I'm up at 7,600. That should be about the same height as this one, because that was also 7,600. And then again, about a similar distance, I know I'm up at 7,800, which is what this initial starting one was over here. So I'm going to try to be about the same height as that one, but still kind of close to these ones. Those are all close together. And then I know that by the time I've gotten over here to T, there's kind of this wider section here, about a quarter of the transect, and that's about a quarter of it. I'm up to 8,200. So let me check that I have all of these in here. This is 74, 76, 78. So I still need one more for 8,000, maybe about here. And then I have my 8,200 at T is right here. So that's how you would put your data points in, reading them from the topographic map. And then I'm gonna just choose a finer line to connect them. And I'll go ahead and choose the same color. And then you can go ahead and connect them to show what that cross section would look like, just what the surface looks like. All right, so it's a slightly imperfect dot-to-dot connection, but part of what you can see is that the low point is where the creek is running through the valley. And you can see that in general, this shape here is that sort of overall shape, right? So you can see an overall V shape to this valley, right? It's not a smooth, flat bottomed valley like what we would expect if it's U shape. All right, so that's what we're seeing when we cross Snow Creek up in Yosemite. And just looking at the topo map, I'm not gonna draw this in, but looking at the topo map, you can see there's a little different shape to this other valley that we're looking at in Yosemite. And just to get us started with G and L on here, I'm gonna go back. I'm gonna choose a different color this time for fun, more than anything. All right, so G, if we were to follow along, it looks like, so these are a little harder to follow because there are so many of them. So this, in this case, it might be simpler to actually find a labeled one nearby and then count down to the point where G is, right? So this says 6,800. If I follow that along, that's the dark contour line above the dark one that G is on. So I know each of those dark contour lines are 200 feet apart, right? So they're 40 times 5, because each contour line is 40 feet apart, and there's 5 of them between the dark contour lines. So since I know 6,800 is the dark contour line above G, I know G is at 6,600. So I'm gonna come over here, find 6,600, and that would be G. That's one end of my transect for this other part. And then again, I'm gonna have to do something similar for L because the contour lines are so close together that they aren't all labeled nearby. So I'm gonna find one nearby that is labeled, and I'm gonna count and calculate what that number should be. All right, so I'm seeing 5,000 here. If I trace it over and then figure out how many dark contour lines to get up to L, I'm gonna say 1, 2, 3, 4, 5, it looks like, to get up to L. And I know each of those dark contour lines is 200 feet. So I've gone up 5 times 200 feet, or 1,000 feet. So there was that 5,000 labeled nearby. I know by the time I get up to L, I'm at 6,000. So over here on the other side for the L point on my transect, I'm gonna put 6,000. So those are the two endpoints of this new transect. It's a little bit higher on this side than it is on the other side, at least for where the transect stops. And then I'm just gonna figure out one contour line down in the middle. So it looks like 4,400 is pretty close to the bottom, the valley floor. And then there's 4,200 is labeled over here. And then there's maybe 1, 2 lines down the fainter lines. So that's about 80 feet down. So I go from 4,200 to about 80 feet, about 100 feet lower. So 4,100. So the valley floor is something like, here's 4,000, is something like a little bit more than that. So 4,100, right? So I'm gonna put that dot there as reference. But part of what you can see here, just looking at it in general, is you have very close contour lines on this side to maybe 1/3 of the way across the transect, or maybe 1/4 of the way. And then you have on the other side very steep contour lines down to about 1/3 of the way across, maybe a little bit more than 1/3. So, and then there aren't many contour lines down here in the middle, right? So I'm gonna also come down about 1/4, a little more than 1/4 of the way across. and I'm going to put a dot that's really close. It's almost the same height as the one I put in the middle. And then on the other side, I'm going to go to about a quarter of the way we said and put that in there too. Similar. So this is giving us a general outline already of the shape of this particular valley. And so you would want to fill in some of the other contour line information here and here. And then you can connect that and you can describe what shape that particular valley is and how it differs from what you see here. So this is what you're doing for question 1 and question 2, right? Is you're putting in those profiles using that draw feature in Word to put your data onto that chart. And then you can do in 3 and 4 some interpretation of what shapes those are and go back to the background material and describe what process creates that shape of valley. And then finally, when you get to 5, you're going to do a little bit of a similar interpretation for Harvard Glacier, looking at A to B. And in this case, you're actually looking at a glacial valley with the glacier in it, still active today, flowing along. So you're now looking at the surface of the glacier rather than the surface of the rock, which we know is underneath the glacier. And part of what you're going to be doing in the lab is the same thing you did before, mapping out the height of the surface of the glacier. So you'll get your endpoints for the transect, map those, map in the other information, map the surface of the glacier. All of that data is in your topo map. And then what you're going to be doing is figuring out, okay, which part of that is the glacier, right? So you can see that you start crossing the glacier here. If you zoom in, there's a little dashed line along the edge of the glacier. And on the other side, you stop crossing the glacier about here and you start climbing up the valley side. So where there's steep topo lines, you know there's steep elevation, there's some high relief. And in this area in here where it's labeled Harvard Glacier, you know you're crossing ice that's covering the rock by some amount of thickness, probably pretty thick for that glacier to be heavy enough to then flow downhill. So in your topo transect, you're mapping the top of the glacier from here over to here. And then what you're going to do once you've mapped that out, sorry, let me pull up my lab again. What you're going to do once you've mapped that out is interpret underneath the surface of the glacier, what must the shape of the rock valley look like, right? So let me do a demo that is not based on the data. I'm going to let you go figure out the elevation points to do that. But instead, I'm just going to do a demo of the idea, right? So the elevations for the Harvard Glacier are more down in this area, but I'm just going to show you the idea. So say this was where A was elevation-wise, and this is where B was elevation-wise. And then you know you have some sort of steep-sided, and you have some close contours here, and you have some here, and then maybe in the middle you have a few that you've mapped out, and that's the surface. You can tell because it's kind of flat, and it's where it's labeled as a glacier, Harvard Glacier. That's the surface of your glacier, right? So you might go connect your dots in order to see what the surface looks like. And you know that in some places that's rock that's exposed, and in some places that's the surface of the glacier. And then what you're being asked to do in this part is actually interpret below the subsurface, what does that valley look like, right? The glacier is filling in the valley, but what kind of shape do you expect to have down here? Do you expect it to be sort of a steep V shape? Do you expect it to be a rounded U shape? And then from your interpretation of what shape it should be, you'll be able to calculate the thickness of that glacier, right? From your interpreted rock glacier interface and the one that you've mapped on the very top of the glacier, you'll be able to figure out what that thickness is of the glacier. So that's what you're working through in part 1, using topo maps to really understand how do glaciers shape valleys, how do we know that they've been present in the landscape or not? And how, with active glaciers, can we interpret and try to understand how deep is the glacier? How thick is the glacier?